It's right here.
Oh, perfect. Thank you. I was looking all the wrong spots.
Sure.
Thank you very much.
Sure. Okay, let's get started. Several announcements. I think I'm missing one. I have to dig into the email to find out what the TA told me, but most of them are here. So first, the TA office hours are not ready yet. I just posted over here, but I didn't imagine that I have to make sure the rooms are available. I know EDC doesn't have any classes scheduled for that room, the soldering room. But however, the lab manager probably doesn't want you to be there, doesn't want to make it too crowded. And so I have to coordinate with these people as well. So I just posted for now, but I have to change it. So don't expect anyone will be there on Monday during the hours post over here. But I'll let you guys know whenever it's ready. I'll update it, okay? And also, I also didn't expect that the TAs can teach all the labs. And since one was teaching labs, it's just myself. I teach like 20, 30 students, which is okay. But now 100 students for 4 sections is impossible because the first section starts at 8 a.m. in the morning and the last one ends at 7:50. I know it's impossible for me to do it, right? So that's why they have all the TAs teach it. And I was thinking the TAs couldn't do everything, but how do you keep the instructors there to just even show up? Probably just stay in the office and then just show up a little bit and then do whatever he or she has to do. But eventually I realized at Mines, the TAs are so good, they can do everything in the lab. And so in the future, I'll probably still show up a little bit if you appreciate that, if that's helpful, I think. And especially for the first section, I even taught it last week, which I shouldn't. But what I heard is I'm paid for the first section, actually, but not the following 3 sections. So I volunteered for the following, most of the time for the following 2 sections, but the last section, that was just too late. I left after 30 minutes, but hopefully you guys made it, okay? But I'm not supposed to be there, just to let you guys know. That's what I heard. Other lab courses, they don't have instructors in there at all. Is that correct? Okay. So don't expect me to be there, right? But if I see issues, I will probably show up. If I'm expecting any big issues or problems, I'll show up a little bit, at least. So the TAs will teach it. So that's why you want to make the TAs happy. And if you're asking me, Dr. Lee, can I make this sound wave like that? If you whistle, someone ask me, right? You are here. Okay, so if I whistle like that, I got a not really normal sound wave. Is that okay? If I say okay, it's probably not the case. The TA is going to be the person to grade it. So I'm going to keep the TAs happy. And they may have different standards sometimes. So whatever they ask you to do, just do it. Because I'm not the person to grade everything. They are grading it. But some of the comments were helpful. I was not requiring guys to use some drives to take the pictures of oscilloscope. Just didn't want to make it complicated since not everyone has a thumb drive. But however, I think one of the TAs required it. I think it's good. You should, actually. There are different ways to do it. You can directly make a snapshot. So on the Tektronix oscilloscopes that I used in my lab tutorial, you can see it's a different interface. So I press the save button. It saves the image to the thumb drive. But even that is still not publishable quality. It shows the figures through the frequency, but it's a black background. You can still change it. You can change the background to white, and so it's not wasting too much ink if you print it out. But also you can export a CSV file, so you can plot it with Python afterwards to be submitted to the paper as a publishable quality figure. Okay, so you can modify it whatever you want, the x-axis, y-axis, the labels, whatever you want to do. If you have the CSV file. So that's the right way to do things. I just didn't require it. However, the TAs require it, you should follow the TA's instruction. Make sense? The TAs will teach the labs in the future. And the reason that it was still beneficial for me to go through most of the labs in the summer. I didn't know the TAs are teaching it. But because I didn't know, so I have to push myself to go through all the microcontroller labs. So I know what's going on. But in the future, I'm not going to let you guys use MATLAB tutorials. It's a big change from next week, okay? Seems like the TAs already taught it in the past, and they really like the structure of in-lab and lab, like what Dr. Carlson have on the website. You see the in-lab and lab, right? So usually the in-lab has a code already provided to you guys. That's what I did in the summer. I just followed the in-labs, it worked perfectly. So some of them have issues. So that's why I was trying to have everything on my website, because I want to let you guys know the bugs and the issues of that website. So I posted everything as step-by-step instructions. So if you follow, but now the problem is we want to go back to his website.
So is it basically like the in-lab is the stuff you do like hands-on, and then there's the code that's separate?
No, the in-lab has questions, has the code that you can directly upload to or download to your microcontroller and run it. You don't need to modify anything. So in the past, what I heard from the TAs is students were able to finish the in-lab before they come to the lab. Is that amazing? So you can also prepare yourself for the lab, actually, which is good. So like what I did in the summer, you guys just follow the in-labs, right? Before the lab, or if you want to do it during the lab time, it's okay. It's what you're supposed to do, what you're expected to do, actually. If you don't do it ahead of time, which is even better, just let you guys know. This is what other people did. The in-labs are super simple. You don't even need a lecture. Just follow it like what I did in the summer. Even though I have a little bit more experience, but it's easy because the code, directly download it, follow the instructions. I'm gonna have my, whatever I probably have 9. I did 9 of them. There are 12, I think. I did 9, but I'm gonna keep working on the rest of 3 for the next few weeks, so I know every single detail about the labs, if there are any issues. Anyway, so I'll also post these lab 1, lab 2, like what I did, the snapshot, step by step, to the website somewhere, or just still the same place. You can also refer back to it if you see issues, because I probably have more details regarding step-by-step procedure for the labs. However, you have to follow whatever the in-lab and lab tells you to do, including the questions. I didn't ask you the little tiny questions, for example, what RA2 is connected to, what RC2 is connected to, all the pin numbers, to where, to what, what's the frequency. I didn't ask that. So in my lab requirements or deliverables, these are mostly just a demonstration, run it, make it work, things like that. Because based on my experience, if you know how to demonstrate it, you will know what the pin is used for. If you don't know it, you won't make it work. So either it works, so it's going to achieve the same outcome. So you guys will be good at programming microcontrollers. However, TAs are teaching it, so we should follow whatever they are comfortable with right now. So there will be 2 assignments. 1 for each lab, 2 assignments for each lab. 1 is the in-lab. The in-lab is due on the same day of the lab. So by the end of the lab, you have to finish all the in-lab tasks. It should be very straightforward, just like what I said. It's going to be just the code provided by the website. You download it to the microcontroller, run it, answer the questions, and prepare for the lab. So the lab itself is actually a project that you have to do for the following week. Does that make sense? So in-lab should be done in the lab. And you can do extra if you want. You can keep working on the lab itself during the lab time, but you don't have to, okay? So you can keep working on the lab, the actual lab stuff for the following week, and then demonstrate it at the first few minutes of the new lab next week, the week after. You know what I mean? So there will be 2 tasks. 1 is the in-lab, which is the report, have all the answers to the questions. If there's a demo, there should be a demo, but they told me there's no demo for in-lab, even though you are actually working on some hands-on stuff, but there's no demo requirements for most of them.
So is the non-in-lab portion something we submit on our own, since it's assignment throughout the week?
It's a demonstration for the week after. You demo the results with the C code. I think that's going to be assignment for Canvas. So you are submitting a C code, just .c file, and so the grader can grade it because you have assignment turn in, right? So you can get a credit for that assignment. And what's going to happen for the week after is you work on the lab stuff, the project for the whole week, and then you come to the lab the week after. You do the demonstration. Just run the demonstration. There's no report requirements, just a demonstration, and the TA will open up that C code. You submit it to Canvas, and you run a demonstration, and the person will look at the C code, see if it's reasonable. If the C code is printing like hello world, it shouldn't print hello something else, right? So it's the original code that you have, not very similar to other people's. It's working, then the TA will directly grade it in the Canvas.
Are you and your partner allowed to have the same lab and in lab? Or?
I think so, yeah. It's going to be the same demonstration, same code. It's a teamwork for the lab. But in lab, I think it's also a teamwork. But I can write it down as a note. Good question, though.
Just to clarify, the in-lab is where we take your pre-written stuff, run it on the boards, usually on our own computers and everything, and then the lab is writing the code and then demonstrating it the following week.
Yes.
Okay.
Could you demonstrate like online where the difference in the lab portions are, or is it like all the same? Does that make sense?
What's that? Say it again?
So like first the in-lab versus lab.
Yeah.
Is it just like all on the same page and you're just doing the demonstration each week, or?
So the in-lab is a different set of instructions, actually. For example, lab 2. So this is the in-lab 2, right? Self-guided activities. It can be very long sometimes, but it's fairly simple.
Thank you.
Okay? So this is what you expect to finish during the lab time, before the end of the lab that week. It's doable. I did it in the summer.
Do we need to do the lab portion for lab 1, or is the thing that we did for?
Oh, the lab 1 is already there. We are not changing anything for lab 1.
Okay, thank you.
It's still to keep the same instruction, just follow the same tasks and get everything submitted. You got the credits. That's it. Starting from lab 2, new policy.
So on your website, Lab 2, is that like the instructions and like the step-by-step and the photos and all that? Is that the in-lab, like, that's just the in-lab and we can
In-lab
still
and
follow
lab
that?
sometimes.
In-lab
That's
and
what I
lab.
did. That's just what I did to finish in-lab and lab.
Gotcha, okay, so this was in-lab and lab. Okay,
Yes.
got
But
it.
however, because the in-lab has a code provided,
Mhm.
so if you follow whatever I did over here, you can probably get the same results. However, the lab is the project. The code is not provided.
Mhm.
Since for the first, I think the first 4 labs I coded up myself. But later on, I found out there's a solution they shared on OneDrive from the previous instructor. So I don't have to code up everything myself. I started using the solutions. So for the first 4 labs, I think that was I coded up, but I shouldn't share it with you on the website, right? So for the lab component, usually it's really short. You can expect that the in-lab components probably covers 90% of the page. At the bottom, there will be a short demonstration, which is showing you if you make it right, what's going to happen in the YouTube demonstration. But you are not submitting any YouTube demonstration anymore. It's going to be an in-person demo during the following week to the TA. The TA will directly grade it. You are having one C code submitted as an assignment to Canvas, and they will grade that C code as your demonstration and code combined for the lab task. So there will be 2 tasks for each lab, 2 assignments each lab. One is the in-lab report, has answers to questions, just a paper, have all the answers. The assignment 2 for the lab is the demo, the C code, with the demo. Clear, right?
Will that be written down on the syllabus or the Canvas homepage?
Yes, I can make it. Yeah, good point.
The demo, we just haven't told like the week after the lab to show that, right?
Yes. Yeah. Yeah. Any other questions? Is that clear? Was the lab good yesterday? I think most of you made it, right? Okay, cool. One quick thing. If you want to do online C code programming or testing, it's only for the first few weeks, because the first few weeks we are teaching C code. I know there are some computer science students in the room. It could be boring to you guys, but just want to let everyone know that in the future, if you find a digital designer job, most likely you'll work on Linux, sharing the server and logging to the server to do some digital design work. Because the tools are so expensive, there's no way that I can install to your personal computer, and they are too big as well for the personal computer. So for example, in the Synopsys, Cadence, all these Genus, all these synthesis tools, these are, for colleges, these are like $5,000 a year, but for industry, it's hundreds of $1,000s a year. There's no one can afford it for their personal computer. So it's going to be a shared, collaborative project, and it's going to be a Linux system. So you should know how to use Linux commands. Have you done that before? You have? Most of you? Okay, cool. And you know how to do VI? You didn't? You haven't? Okay, but it's okay. Have done VI with editing in Linux. Okay, cool. But I will give you a chance to learn it if you want, but it's not some required work. It's an embedded system class, even though, so in first college, embedded device class is IPGA. IPGA based embedded system. Here is microcontroller based embedded system. Can be both, either one. It's okay. However, because it's more digital design oriented, so we usually require students to do Vim at the very first week. There will be a pretty not hard, but medium difficulty level quiz just on Vim. I usually sit with the students. I have a paper with all the commands telling the student, do this, copy, paste, change the line. There are like 50 commands to follow for the first quiz in the first week. So students are prepared for working in a Linux system, which is great. So I'm providing you with all the resources on my website, but you don't have to do it since it's not required. But I still want to let you know. So for example, here, go tutorials. If you see C++ and just tutorial 1, you'll scroll down, you'll see how I install Cygwin, which has all the compilers in it. So it's a GCC compiler that I put into the environment variable here, so you can directly open up from the command line like that. Okay. So the goal is to have. So that's for compiler. That's for the C compiler. For the editor, it's just a free version of the gvim. You can follow here, install gvim, and also put into the environment variable as well in path. So that's gvim. So you can open vim in your command line. You can also open gvim somewhere else individually, but command line will be. It's not easier, but it's it's probably more similar to the Linux system. That's what I want to say. Okay. So for example, since I used this with the C++, so I just tested 30 minutes ago with C. It worked. So it's a last minute testing. This just came to my mind. I was thinking you guys need to do it. So that's why I spent 30 minutes before class and it worked. Because Cygwin has C compiler as well, not just C++ compiler. So if we, for example, if I create a folder, but make sure the directory, the path doesn't have any space or other weird characters. Just make it letters to a path. So you can create a file. For example, what I'm putting here is the test.c file. You want to display the extension, so you can modify the extension of the file. That's important. Okay, so it must show the extension, so you can modify it. So I'm changing that to .c. And in here, the way to get into here is definitely you put into the address and Control C, right? Since I'm already in this directory. But in the command line, you just right click. If you copy this, right? If you copy it, and you come to here. So, if I quit this one for one level, and I get into this level, the directory I want to work on, and oh no, so I want to enter, for example, CD, right, and right click. Right click is gonna directly copy this to this window, and I press enter. It will get into the working directory. No matter, so for example, if I close it, okay, I do command line, Okay, so somewhere else, pointing somewhere else. I just do CD and right click. Will directly get into my working directory. So you can start using, if you have gvim, put it into your environment variable, you can open it up. Use gvim or vim. Vim will directly open it up in the command line window. If I put test.c, so it's going to open it up like this. Okay, so and then put a column here and quit without saving. It will come back to the command line. And you can, if you want a better font size, I think you can always right click here, go to properties, and I think it's font, and just make it bigger. Right? So if you want to run it, want to test it, so you can always do GCC, because I already, if you do dir, you can show all the files in here, and the file I have is test.c, right? So if you want to execute it, it's going to be GCC test. So you know there's just one test, right? Just press tab. It's going to show it, show you all the different options. And .o, it's going to output a test.exe file. Okay, so you can compile it and give you an executable file. Press enter. So that runs if it's not reporting errors. And then you can directly just do this, okay? Just it's executable, just directly execute it. Okay? So it's showing 1, 0. Why? Because if you open it up, it's printing 1, 0. It's something we are covering today. We're trying to, oh, it's too small, right? So that's why you want to show a bigger font size. See if we can do 72, see if that works. Okay. Okay, now let's get to the code. This is what is on the lecture. Okay. Include the standard IO library header file and include the definition of these unsigned int specified in the embedded system. They want to specify the size of the integer. So it's unsigned integer 8 bits. So if someone asks you what's the size of the integer variable, it depends, right? It really depends. Different system, different computer systems have different length for integer data type. So unsigned 8 bits, we like to do that since we are directly dealing with hardware. We really want to specify the length of the data we are putting in there. That's important. It's different from computer science and computer engineering. Okay? We want to make super clear what we are dealing with since we are touching the hardware, not just programming on the keyboard. Okay? Unsigned, oh, this is a return type, so it's returning a 8-bit unsigned integer as well. It's a main function. In your microcontroller, it's gonna keep running this function back and forth. So in Arduino, what's the main function's name? Do you have experience with Arduinos at least a little bit? What's the name of the main function in Arduinos? Have you done that before? It's a loop, right? L-O-O-P, loop. Same thing. So when you run it on the microcontroller, it's gonna run it back and forth from top to bottom, unless you manually, interrupt it or something. It's gonna run back and forth in the main function. Okay, so for the first variable I put a 0 for this variable. I have to specify this local variable because it's within that function, so it's local. I'm giving a 0 to it at the very beginning. So how many zeros do I have for this variable? I put a 0, however, the compiler is going to compile it and show how many zeros. 8 zeros. Why? Because I specified that, right? It's an 8-bit unsigned integer. Got it? So it's going to be 8 zeros, even though I just put a 1 0 there. So this is decimal, right? This is decimal. So in Vim, so
then how come when you printed it out earlier, just to display it, it only printed out one integer? It only printed out 1 bit.
because that's decimal.
Oh, gotcha. So it is printing it out in decimal.
Yeah,
Gotcha.
yeah, yeah,
Thank you.
yeah. So I have to specify, if you want to print out as a hex, you have to do a specifier here,
Gotcha.
which is a really good question. This is bringing up this next thing here. So for Vim, you just have to be used to it. You press J, it's moving the cursor down, right? And you press L, you are moving it to the right. So you are basically not using the mouse. That's the goal. That's the goal. Computer scientists hate mouse, hate the mouse. So it's just a keyboard, right? It's like keyboards. And moving down, see, I made a mistake. Moving down is a K, right? K. K is moving up. J is moving down, all right? H is moving to the left. And you want to replace anything, just press R. For example, I want to replace this one as 2, right? R, and then do a 2, okay? And you want to delete the whole line, DD. And press U is undo, right? Press R is replace. So what's the redo though? Control R, I forgot. Oh, Shift R, oh, Y? No, Y is copy. Anyway, so why is this important? Actually, sometimes if you have experience, you know this is critical. Because when you open up the script in Linux, a lot of times you do the digital design. After you do the synthesis, it reports like hundreds of pages of scripts or outputs to your Linux output file in Linux, right? So how do you go through the outputs to find out the valuable information in there? So by that time you see the super long document as the output from the digital design. Actually, Vim is quite useful because you can move the cursor to the top and bottom without scrolling that mouse scroller in the middle like crazy for 5 minutes. For example, I think it's GG. Capitalize the GG, 2 G's will move the cursor to the bottom. Even though we have a short thing, but it's actually moving to the bottom of the page of the script. So lowercase gg will move it up to the top. So a lot of times you can directly put the cursor to the top and bottom. If you know the valuable outputs sometimes are placed in a certain place at the top or bottom. You don't have to scroll it in Linux, right? You can directly just press the shortcuts. Yeah, we're not teaching Vim, are we? We don't teach Vim.
There's a thing called Vim Tutor. If you're on Linux, you can just type in Vim Tutor and it'll run through commands.
That's great. Yeah. Okay, good to know. And operators, the assignment operator, it's just a giving variable 1 to result. And there's a plus is increment operator here. It's what's this one doing is it's assigning. So if you have plus after that variable, it's do the assignment first, do the operation first, and then add 1 to it. So for this case, could you tell me what is VR1, what is result? If I run it, VR1 is 0, right? Oh no. No. The other way, right?
Yeah.
So VR1, so for, like what I said, if you have that the trailing plus after that variable, is actually doing the operation first and then add 1 to the variable. So what's the operation here? It's assignment operation. It's assigning VR1 to a result, right? So it's going to assign VR1 to result. Yeah, I have to change this one to 1. Okay? Originally it's 0, right? So it's going to give a 0 to the result first. It's going to hold 0 in there, and then VR1 will plus 1. So eventually VR1 will be 1, the result will be 0. And you know, when you are dealing with the C programming tasks in the first 4 weeks, only the first 4 weeks. I think after the first 4 weeks, it's going to be totally just embedded programming. You can always verify your C code in here, but it won't be able to 100% translatable to your embedded system because they are using different compilers. And I'm not sure if they if they need this header file, they probably don't need it. I think it's called xh.h or something, includes all these definitions in there. So you don't have to use whatever we are using here. However, for the main algorithm, will be the same. So I'm still thinking this is a pretty good way to test your SQL really quickly. But it's running.
What's the first parameter in printf? What is that? The percent %d?
Oh, that's this is it's called a specifier. I have this printed out. This is something we are trying to cover today. Actually, it's also on the course website. You are always welcome to review it if you want. So Dr. Carlson did a really good job on that. If you go here, go to the website, you see the lectures. See how much work he put in there?
Yeah.
It's awesome.
Love course.
Go to lecture 1. Apparently we didn't follow lecture 1. Lecture 2. Apparently we didn't follow. We haven't followed exactly. However, we'll cover whatever has to be covered in the lectures in a different way or similar way. Anyway, so we are teaching tools complement, so you are ready to do the homework, which is due next Wednesday, right?
Mm-hmm.
Okay, so today we are talking about this, right? Integers. Specifiers are being put in, not here. Let me see. See if it's on lecture 1. Oh, he didn't put the specifiers anywhere. So I think I found it somewhere else. I might be wrong, but anyway, so here's a table that I have. Can cover most of the cases. So what's happening is when you are printing out a variable, it's not super clear, I'm sorry for that. I'm trying my best. Okay. Could you see a little bit on the back? Not really. I'll just write it down on paper probably. So specifier specifies the format of the print function.
It's actually on lecture 3.
Oh, lecture 3?
Yeah,
Okay.
It's out with the different like decimal whatever.
Okay, good to know. All right. So please refer to lecture 3 if you need more information. You can always Google, just type C code specifiers. You'll see even more details. And so percentage sign D, I'm just letting you guys know the most common ones. There are just so many of them, but let's just talk about the most common ones. Percentage sign of D is the decimal, so it's printing out a decimal variable here. And it's signed. It's a signed decimal number. If you put a D here.
So does %d make it sign?
No, it's just separating the variable from all the other text characters. So you put a lot of times you have a quote here, right? So usually you are putting a character in there, like a text, a letter or something, okay? However, you want to also plug in variables. Let me try it. Let me show something for you. So for example, I start insert. I press I. So it's going to insert in front of it, in them. This is going to be text because I don't have a percentage sign in front of it. This is, okay. And now I colon, write, and quit, okay, and run it. This is the code you want to run, so press the arrow key to bring it back. Run it, and then run this. So it's going to print out the text with the variable in there, so it's not all text. If you don't have, did you get that? Did everybody get that? So this is a variable it's not showing a person, sign, and D. It's showing the variable. So you can print something else instead of just the text. So if I go back to that thing. So what if I wanna print a, for example, a hex number? So I want to change the numbers. Yeah, let's print out the hex number. So I think on the website it shows X. However, it didn't work for here. Probably it works for the embedded systems compiler, but I think it didn't work for here. So it's an X is not showing a hex file. So I do write and quit and run, compile it and run it. It's not really changing anything. However, if I because VR1, if I want to print a hex file, wait.
Yeah.
Say again?
Make var1 10 to see if you get A as the hex number, because 1 and hex number 1.
And if it's like 9 and then the 8.
Yeah. Good. Thank you.
Oh, I see, it doesn't.
So if I put a plus plus sign in front of it, what's gonna happen?
They're gonna both be the same thing. It's gonna increment after. It's gonna increment it before you set it to results, so the soul will do the same thing when you print it.
It's gonna increment it first, right?
Yeah.
So both will be 10, right?
Yeah, they'll both be the same. They'll both be 11.
One will show. So wait.
Well, yeah, the one is still coming out as dust.
It's adding to itself first and then assign to it, right?
Yeah.
So it's gonna be 11.
Yeah.
Both are 11, right?
Yes. Because B's 11.
Yeah. Make sense?
Yep.
So X is actually correct, but on the website it shows H. So hex, don't use H of hex, use X of hex. All right, so we can try more specifiers if we want. Let me see, there's another option.
What is the /n and the /r?
Oh, that's change the line. Good question again, thanks.
Oh, like carriage return? Like
Yes,
new line?
yes. I think R is returning, new is new line, R is returning to the front of the line. So it's always, I mean, for example, if we don't do, let's try it. I'm probably wrong, but one of them is change the line, one of them return it back to the front of the line. Let's try it.
New line is new line. And
New line is
it's
new line, so R should be returned.
return.
Yeah,
Carriage
I think so, yeah.
They need both to see, I think.
Yeah, yeah. So if we just do this, we are not seeing any difference, I think, right? However, if we add this one to it, we do this, it's gonna show a good result, but you know. What about, let me see, other specifier I wanna try. I think there are problems in the homework. Let me show it. Okay. The students ask that question, so I think most of you have the same questions, right? Let me see, which problem I want to show you. Okay, here. First, before we get into that, let's say two's complement, and we all know that if it's signed, two's complement is signed, right? There's no unsigned two's complement.
Yeah.
So it's all signed. We are talking about two's complement. And then 1, 0, 0, 0. So the very front one will be negated. So it's actually negative 8 is not 8. That's how you do it. Usually, but the most traditional way is how people convert it to the negative number in 2's complement. For example, 0, 1, 0, 1, right? It's 5. So 5, if you want to convert to negative 5, you flip it and add a 1 to it. That's why it's called 2's complement. So you flip it, you're getting 1, 0, 1, 0, and add a 1 to it, you're getting 1, 0, 1, 1. Okay? So this is negative 5 in 2's complement. However, in the real world, right, in the nature, is this really negative 5? No. I put a digit here, it's 8. Like what I said in the first day of the week, I think $1 is $1. Why I give you $1? You said it's negative $8, right? Negative $1 or something, right? Why? It shouldn't. However, we faked it that way in the computer system because we need the negative numbers to be represented in the memory or in the whatever, the CPU, right? That's why we did it. We defined that way. However, it's not really negative 5. It's not really negative 5.
So if we switched a 2's complement number to hex, would it still be the same if it was signed or unsigned?
It doesn't matter if you. It's just a number conversion. You convert that binary number to hex. It's just a different format. However, if we define it here, if it's signed, unsigned, we should specify in front of it. You know what I mean? So for example, AA, right? 0xAA. You just don't know if it's signed or unsigned if I don't specify that. And if I don't tell you this is 2's complement, you just don't know. It could be a positive number, or it could be a negative number. I just have to specify that. You know what I mean? So, for example, this number is 0x AA, which is in binary, is 0B what? 10101010, right? Why is this always being used in digital? Because it just has all these LEDs. You can, and it just exists in a lot of example code. You use this number and XOR with this. What's happening? Yeah, switching, right? It's like, oh, you have 8 LEDs, or like this, 8 LEDs. Okay, it's doing this kind of blink for the embedded system, just kind of fun. It's just usually a very typical example for the first C code on microcontrollers. That's how you do it. That's how that works. Hello world, yeah, like hello world in C, right? Okay, so you should know that this is not really negative 5, but we treat it as negative 5 because we define it that way in the computer system. So in that case, because it's not really negative 5, so when you are doing the addition, subtraction, multiplication, you're getting errors. Does that make sense? Because that's not a real number, but you are following the same rules to do all the operations, you are seeing errors. So we have to define another set of rules for the operations to get rid of the errors. It's like you tell a lie, you have to tell another lie to make the first lie work, and just bad example. Let's see one example in 2's complement, okay? Signed 2's complement. 101 plus 101, what's gonna happen? 0, 1. Yeah, yes, overflow, yes. However, don't confuse with the carry out with overflow in specifically just in here. Sometimes we talk about overflow in, sometimes you're getting like 8 bits in the memory bank. You're getting this, and you add a 1 to it. We're not considering the sign at all. So you're adding a 1 to it. It's getting overflow, right? Because you're getting 1, all zeros. That's another context. But for 2's complement, we have a slightly different definition for overflow. So overflow only happens for PPN or NNP. Did you learn that?
Yeah.
There's only cases for overflow. Sometimes you have PNP and it's carrying out. However, it's not defined as overflow. Why? Because we are going to have a different rules for these two different situations. Because we have the wrong numbers in 2's complement. That's why we have to specify that when we want to do what in the digital system. Seems like complicated, right? But now let's get into it very quick. 4 minutes left. So this is what? This is, if it's 2's complement, for 2's complement or 1's complement, doesn't matter. If you have the MSB to be 1, you know it's a negative number, right? For sure. And so this becomes n, right? It's a negative number. It's another negative number. And if you don't look at this one yet, when you are making a judgment, you shouldn't. Don't look at the carry out yet. Just look at this MSB. Is this n or p? P. It's a 0, so it's a positive number, right? Okay? So n you got a p, is that correct? I owe you negative. I owe you $8, but however, eventually you owe me $16. So negative, this is negative what? Very quick quiz question. Negative 3, right? So minus 4 plus 1 is negative 3. So negative 3 plus negative 3 should be what? Negative 6. However, you are getting what?
Positive 2.
Yeah, positive 2, so it's not right. So I have to deal with the carry out here. However, in this situation, because it satisfies one of the scenarios, so it's NNP, right? NNP. So it's called overflow. What you want to do for overflow, especially in digital system when you're programming with FPGAs. There's a very good example for this case, which is a 3-bit full adder. So 3-bit full adder is also doing a subtraction as well, and you have to use a digital. I'm going to show you in Verilog to manipulate the MSB. That's where you understand in depth, like why we are dealing with 2's complement, why it's wrong. However, let's just take a look at this example. So when you have overflow, you just have to adopt the carry out. Just adopt it. So you are getting the correct answer. So now you have this one, which is negative what?
6.
No, this is, yeah, but yeah, so just this digit itself is negative 8, right? And this is plus 2. So negative 8 plus 2 is negative 6. So it's getting you a correct answer. So that's how you deal with it. You just have to adopt that MSB in 2's complement when there's overflow.
How would you like code that in and like see how like because
You don't worry about that
okay
because that's a different layer of engineering.
gotcha
That's what I'm saying is when we care about the adopting, removing, that's IPGA level programming with a full adder IPGA level. How we do it? Concatenation. Okay? So full adders, we do the addition, we are getting S2, S1, S0. You adopt C2, just put it at MSB. So IPGA is going to do it.
gotcha
For C language, it compiles and do everything for you. You don't have to worry about that.
gotcha so you just adopt the MSB into like the
Yeah.
thank you
All right.
thank you for the lecture.
Sure.